And thank you first of all to Mr. Nagar for raising the point. Chalta hai attitude, and humko kya farak padta hai, and those kind of points, And this entire presentation will be to address those real problems. And this problem is not only India, as we see that, India will have these problems. It's there globally, and everybody is improving. The topic is passive fire protection. Passive fire protection in India has been a topic which was, I would say, studied but not studied in the aspect which it has to, and the importance which it has to. And there was also a point raised by Mr. Nagar of CAPEX and OPEX, and this also addresses some of those aspects as well. So just go through the presentation, and please feel free to ask any questions if you have in between as well. I just wanted to show you this fire. Just don't know the name because these fires happen in various other places as well. But let's have a look at this fire. Can you raise the volume?
The fire broke out in the basement of the hospital, after which toxic fumes then spread throughout the hospital. It's a 7-story building. This is Annex 1 of the AMRI hospital. The license of the hospital has now been suspended, and an FIR has been lodged against the management of this hospital. Many questions being raised about the response of the hospital to the tragedy. Locals alleging that they were the first to react, and that the hospital, in fact, authorities.
That's all. Just wanted to show you the quick clip. You would have seen how I think he was a doctor who was evacuating from the hospital, and you see the way he is evacuating the hospital. And the news also, it says the toxicity of the smoke, and as he also mentioned in the introduction, that smoke is something which causes the real problem. Focusing on to this case study, and just to highlight the importance, this case is also studied in Harvard. In the disaster management subject. This case is also studied in Harvard. In this subject, if you see, the fire happened in the basement. And basements are the places where you keep things, either for parking or for, there is some other utility place, normally not so often looked upon. Even in the audit, you might, get to leave it. I have done myself 400, 500 audits in India and even outside of India in US, and this problem persists everywhere. And normally these small things, housekeeping, they make these fires grow even bigger. In this fire, the point was the fire happened in the basement and then it reached to the up top. Now the question which was asked and also being reported, the fire department responded to the fire after a certain amount of time, half an hour, 45 minutes and all that. So the fire could grow quite a lot. But nobody asked the question, why did fire grow from a basement to the ground floor to the first floor and all that? So that kind of questions are missing. So this is one case study. And if you see, this is happening quite a lot as well. Bhubaneswar fire. Many of you from hospital industry, you would be knowing this as well. In this, the fire happened in the dialysis ward and then started spreading. Now again the question was not asked, why did the fire grow from that ward to the another ward? Because in the National Building Code of India, even before, the compartmentation of the aspect was anyhow highlighted. But then the question which need to be asked, now again, when I was hearing Mr. Nagar, I was really enthusiastic, and I like the sentence, regardless of the class you come from, lower class, middle class, rich class, fire safety aspect is something which everybody needs. You cannot build a hospital which is quite, of glass and then you do not address these problems. Yeah, this is everywhere. Now, so the basic question, where exactly we are missing. So just wanted to show you from this slide that there is, for any fire, consider this room, suppose if this room goes on fire. Normally when a fire happens, you have a smoke detector which is also installed on that wooden thing. So what smoke detector does is, it detects the fire. So first of all, what you have to do is, you have to know where the fire has happened. Otherwise you keep running to know that alarm has sounded, now where is fire? So you lose a lot of time. So you want to detect the fire, number one. Now when you have detected the fire, that fire is there in room number something. Then you want to contain the fire. For example, the Singh fire or AMRI fire. If fire has happened in basement or dialysis ward, it has to be contained. Otherwise, the moment it spreads, your entire system to defend the fire collapses. And as long as you can contain the fire and detect the fire, suppression becomes very, very easy. Yeah. And third thing is suppression. When you have detected the fire, contained the fire, then comes the picture of suppression. For example, sprinklers, extinguishers, which are also kept here. So all these things comes into play. Overall, all three aspects have to be considered holistically, and most importantly for the hospital industry, because hospital is one place where the occupants are most vulnerable to defend or run against the fire. That is why the evacuation time in the building code and all the different regulations have been always called for more and more gap time. Yeah. So that is one aspect. Just wanted to show you this video because it will tell you how really the fire and smoke spreads. Normally it spreads from the places which we don't get to see quite often. Can we play the video? Oh, can we play the video?
Typically, 5 minutes is all you get. Fire, and especially smoke, spread through a building much faster than most people think. Every year, about 3.8 million fires occur worldwide. While damage to assets is in the billions, the yearly death toll amounts to 45,000 persons. Much of this could have been prevented if correctly installed fire protection had been in place.
Architects, planners, engineers, and building owners are responsible for effective fire protection. Oftentimes, they do not realize that fire stop is not an option. It's a clear legal requirement, and negligence or improper execution is a violation of the law. Nearly 60% of fire deaths are not in the room of the fire's origin, and 3/4 of all fire deaths are caused by smoke. When there are through penetrations in walls and floors, toxic smoke easily spreads to adjacent rooms. The keys to effective fire protection are both active protection, such as detectors and sprinklers, but also passive protection. Passive means that penetrations in walls and floors have been sealed with approved fire stop products. This principle is called compartmentation. When installed correctly, fire and smoke won't be able to spread from one compartment to another. This allows for safe evacuation of people and protects valuable assets. The thing about compartmentation and fire protection is it's only as good as the products you use. One always thinks that accidents only happen to other people. That's a false conclusion. It is the responsibility of architects, planners, engineers, and building owners to protect lives and assets by effective and well-designed compartmentation. Hilti offers innovative and legally compliant, internationally approved solutions. We recommend Hilti to be on the safe side.
So with this video, you would have got an idea like how smoke goes above the false ceiling and then spreads. And that is just one way of spreading the fire. There are multiple ways how it spreads, depending on the combustibility of the room. In an industry, it might spread even faster. Now going on to the next slide, as we have seen these case studies. Now, just wanted to focus the discussion on these three things, these three books. One is the National Building Code of India, which was revised in March 2016, it came out. Then the ADMA guideline for hospital safety, and then the NFPA. NFPA is US-based association which makes the regulations and recommendations on hospitals. Let's focus on what National Building Code of India says. So, National Building Code of India categorizes hospital building under category C. Before, in 2005 version, many of you might have seen it, the scope of the NBC was only a 3-line definition. So people can use it, get confused, or use it for their own understanding. And then the challenge, when something happens, everybody here and there gets blamed. Yeah? So at least this time, collaboratively, democratically, they have tried to expand the definition of this thing. Now, if you see, it very clearly says all the high-rise building, this NBC recommendation applies. And the moment that state adopts the NBC, this becomes part of their bylaws. Yeah. So, just wanted to show you 2 points from this slide. One is that this applies to all the high-rise buildings. High-rise means 15 meter and above, and hospital is categorized under classification C. And then the NBC also says, for example, this room, for example, if it's a hospital, classification C. Now, how do you define the wall or the door or anything which penetrates the wall? For that, you have to have something defined as a rating, and that is called as, in the NBC terms, fire resistance rating. That how much of this wall or fire stop or door can resist the fire, and then there is a rating given to it. And in a normal building, for example, you have to have something in place. You can't make a compartment completely solid of 2 hour rating and then nothing inside. For a practicality, you will have some breaches, pipes, electrical tray, or above fall ceiling, sprinkler pipes which are going on here, all those. So just by the picture, I wanted to show you that. And this is a slide because with the growing fires in the country, and then the importance of fire stop systems and compartmentation, NBC have also realized, the Bureau of Indian Standards have also realized. And if you see the definition of 2.32, fire stop, before it was just a 2-line definition. So I used to hear those cases that sir, इसमें we put normal cement, कुछ भी मतलब लगा देते हैं, कोई देखेगा तो है नहीं. Because I was an auditor that time, and I myself was not too aware of fire stop systems. So in my own understanding, you might allow it, yeah. But for you all here, we all are here to tell you that fire stop system is something which is rated. A normal cement or normal things which are considered as fire stop systems, unless they are given a rating which are defined in NBC, they will not be called as fire stop systems. Those which will have a rating as per NBC, they should be called as fire stop systems. Otherwise, you might install anything that will not work. And then that causes the problem later. For example, AMRI fire or maybe smoke and many other fires. Fire is happening in the basement, going through the pipe or duct. Was pipe sealed? Maybe it was sealed. Was it sealed by the tested fire stop system or something just like that? Because nobody was knowing it. So that is a big question.
Does the NBC say what kind of material to be used for fire stop?
No, actually. Because NBC will not recommend for material. NBC recommend the concept. Now it is all up to the site and site condition. You can decide that it is if it is a maybe cable tray, then you have to have a certain kind of system and all that. So again, coming to the rating, there are 3 ratings which NBC asks. One is the stability, that your system should be stable, or a fire door. You consider fire. A fire door is nothing but a fire stop, by the way, because it stops the fire. And then there are fire stops for cable tray, for cable tray penetration, for pipe penetration, and all those things. Those are also fire stops. Now, suppose if this fire door has to be classified by evaluating 3 ratings. One is integrity. What is integrity? Fire happens in this room, should not go to the other room. That is integrity. Insulation is something, fire happens in this room, but the heat also should be very, very limited to the other side. So that for a particular amount of time, it should also not ignite something which is kept outside. That is insulation. And then third thing is stability, so that your system should be stable. For example, fire door, it should be stable. It should not be so that after a certain amount of time, it just fall off. Again, big problem. So those 3 things it says. Now, coming to the other book which I mentioned, NDMA guideline. NDMA guideline is even more detailed for hospitals actually. And it has a clear actually separate heading for fire stops in the hospital section. All openings in the door floors shall be protected by certain. So I will not go into the detail, but just wanted to highlight that in this guideline under 6.3.14, it's very, very clearly mentioned that where all you should install fire stops. For plumbing, for cable, for electrical, optical fiber, all those things it's mentioned. Size of opening, no, because that depends on the actually architect and designer as to what kind of design he's making. Maybe he's putting one pipe and then he goes to 2 pipes. But in NDMA, it's not there. And then I just wanted to highlight you the global one. Now, this is from NFPA. This NFPA is similar to FSAI, what we have in India. They are quite old in this, quite global association. They have the guideline for hospitals. Now they say that fire stop systems, again they highlight for cables, for plumbing, for optical fiber, similar to what NDMA says, but they have a bigger description. And they also mention, because in our NBC or NDMA, nowhere it is mentioned that what kind of standard you should go for. For example, now I want a fire stop system here. Now what kind of standard should I go and test it? I have one Indian standard which I can go for, or other standard. Or NBC also mentions some confusing language, approved and accepted standard. Now what is the approved and accepted standard? That's a question. So all these things, but in this case if you see, it says ASTM E814 standard. Very clear. It's because that standard is meant for testing for fire stops. And then you have electric code, except which I have added just for you, just below. That also highlights the importance of fire stop for electrical openings. Because mostly in all the forensic reports of fire throughout India and even globally, you get to know that fire happened because of electrical ignition. And also they mention the probable cause of fire was electrical ignition, because you really cannot define what was the cause of fire. But even if you agree that electrical ignition was that, electric code says that you have to have stopped that opening from tested fire stop system so that you contain the fire within that compartment itself and save life of the occupants, and not only occupants, even the fireman who goes and saves life. Because in Lotus Business Tower fire Andheri, we have one fireman who expired, saving the lives. Although media did not show it, but that was a very, very unfortunate event. Now misconception. Now so the misconception, I just added one. Sprinklers. Sprinkler is a fantastic technology, by the way. It suppresses the fire very, very fast. Now, there are some misconceptions with this, along with sprinkler and the red pipe which goes around the premises. That's called as hydrant. Now, the misconception is that if I have sprinklers and hydrants, I am very, very safe. And the rest all I will see what I can do. But just for you all, just wanted to focus on this, because I used to design a sprinkler system before and do the hydraulic calculations. This is a lot of calculation better. But what the crux is, that sprinkler is designed for a particular amount and number of sprinklers operating at one time. The moment one more sprinkler or two more sprinklers open, for example, if it is designed for 10 sprinklers, the moment 11th sprinkler opens, your entire system design gets overtaxed. And this excerpt is from the FM Global guideline. FM Global is regarded as one of the stringent sprinkler guidelines in the world. And then comes NFPA. And in the stringent also, I just did the calculation, 7 sprinkler it is coming. The moment you open 8 sprinkler, you are overtaxing the entire design. And which is where the fire stop system comes in place, that you should contain the fire within that compartment itself, and then only you will not open more and more sprinkler heads. And you will keep containing the fire within that compartment itself, easier to suppress, and that is what the intention of sprinkler as well. And also, because it's a discussion on hospitals, but the moment you go to Class B fires, Class B is nothing but the moment you go to industry fire, oil refinery fire, you will, for example, Jaipur fire, I will take the case. Jaipur fire, there were big fire, news was reporting. There were 2 oil tanks, big tanks which were on fire. One tank on fire. What was fire department doing there? Fire department was not putting the foam on that tank. Fire department was putting the foam on the other tank. Why? Because that fire is already heated up. They wanted to contain this fire from the heat transmission and all that. So that is why containment comes very, very handy in case of all the fires. Now, in hospital scenario, the typical application where the real penetration happens, and I would say the real fire grows from these places as well. Now these are pipe penetrations, Bhubaneswar fire, electrical cable penetration, and then HVAC penetration, AMI fire case. These are the three major penetrations which you see in many of the. There will be more also, there are facade as well, and then so on and so on, major these are things. And what our code says, code will always say the minimum guideline that we should maintain as a general guideline, you know. But can we treat hospital as hotel? Definitely not. Or maybe can we treat hospital as normal office? Cannot be. Because hospital has a different type of occupant who cannot just run like normal people. And then hospital has a different thing anyhow in the occupancy, maybe gases, medical gases, so on, so on. So it cannot be treated as a normal occupancy. And then comes the spread of air. Maybe some area is cordoned off for a patient who is suffering from some illness. That air should also not go to the other normal HVAC air. And so on and so on. So there are some aspects which you might need in a hospital along with those fire stops in place. And one is the smoke leakage. As we knew, just discussed also, smoke is the killer number one. 75% of the time people die because of smoke. There was a fire in London, very big news, and there's a lot of research study which is done. We have also done many studies. People died for smoke, and also there is a video on YouTube mentioning with a caption, scary video of Grenfell. You see that video how that person jumps out of the window because of the inhalation of smoke. Why inhalation of smoke is so important? Because inhalation of smoke has a very toxic contents. Now you are actually doctor, so you will know much, but there are some contents which hallucinates, which I have also felt in my fire protection training. That is why all the fire men, they also have to have the smoke apparatus. Otherwise, you will yourself either make yourself ill or you will hallucinate and then you will do something else. That is why people jump off. Hitler used to give this HCl gas, and that is also one of the gases which gets produced out of smoke. So movement capability, just focusing on this slide. Smoke leakage is one thing. Mold and mildew is the other thing which people normally ask in hospitals out of these requirements. And then the movement capability. For example, you are in a earthquake zone, or there is a vibration, or there is a, all these things. Or you have a chance of movement of the pipe or electrical tray, all those things. And then this comes in, and this aspect comes in handy. And the good thing is, fire stop is maintenance free. Once you install it, done. It will be there. It's just that you have to install it with the right installation techniques and all those things in place. And that is where the operating cost comes into picture, that you don't have any maintenance cost for that. Now, going back to the power cable penetration, just quickly wanted to touch to this slide that depending on the need you have, for example, you just need fire rating. Or if you need fire rating along with movement capability means that you think that my cables will move. I am in an earthquake zone of zone 4 or zone 5. Anything can happen, so I will go for a movement capability additionally. Or if you are thinking of something which has an explosion area, and in hospitals you have medical gases, oxygen cylinders, which will be kept either in the basement or outside in a cordoned off area, chained and locked. So those areas, those are explosion prone areas. In that cases, if there is a wire going on, electrical wire going on, you would like to have something which has a blast resistance also. Yeah. So depending on the need you have, there are various kinds of fire stop systems available you can choose from. Same thing for HVAC. Depending on what you need, you can choose from. And you need not go for anybody else to design, by the way, for fire stop systems. We have our own website from which you can design, and you have a third party called UL who does the certification as a neutral agency from US. From there also you can choose and design your own fire stop systems. You get to know an idea that yeah, for this I will need something like this. Very, very easy. Then for low voltage as well, same thing. So I will not go too much into this slide because there is also a demo kept outside. You can have a look at it. That will be a very fruitful discussion. Now, coming to the topic of movement, because this is a very crucial thing, not only for fire stop, even for sprinklers. Normally, for example, most of in India, either in zone 3 or zone 2 and zone 4, all these three only. And post-earthquake fire, whenever the earthquake happens, the post-earthquake fire is something which is quite a frequent phenomenon globally. Japan, this is a table which we have from the resources. Just take the Kobe example. After this fire, there were around hundreds of fires which happened frequently. Okay, I'll just finish here. So hundreds of fires frequently, and then there was a hell of a loss of property, lives, everything. So that is why the earthquake aspect is very important. And when earthquake happens, you have a very, very big chance that the piping which you have might break off or might crack. And that is something fire stop system addresses. And there is a standard HES2018 which tests the fire stop system for earthquake. Similar to this, you have various other things also. For example, if you are thinking of a green building, then fire stop systems addresses that aspect as well. Acoustics, so on and so on. Now, whatever I just told you, suppose if it is tested by ASTM, all that, US agency, Dubai, all that. Now, whether it will work for Indian condition or not, how would I know that? This was a very big question in the industry, and then, so what we did is we partnered with UN, Underwriters Laboratories. They are headquartered in Chicago, but they are also present in India, Bangalore. They have a very, very big fire protection team here in India. And we partnered with them and the Indian Institute of Technology, Gandhinagar, who helped us study this model, and they built a 3-story building, and we set the 3 buildings on fire. Not only once, twice. And then we wanted to study how the fire grows and what is the role such system play in restricting that fire. And I will show you the video, which is very basic. It will not give you very, very big everything in detail, but just quickly have a look, you will get the glimpse. For detail, you can contact us anywhere. Can we play the video?
Recent fires around the globe have shown that the rapid spread of fire and toxic gases within a building are among the main causes for big losses of assets and people. These cases raise the question how we can better avoid the propagation of fire. Key is to contain it at the place of its origin. This allows people to escape safely. In partnership with UN, we have studied how a fire behaves under real conditions. As a result, we found that the use of unsuitable materials and construction elements, for example facade panels, are not the only reason for dramatic development of fire in a building. It is also essential to avoid the spread of fire at every opening in fire-rated walls and floors, and also on perimeter seals in both curtain wall facades and linear joints.
For talk to architects or consultants, they feel that a rated wall or a rated fire door provides a passive fire system, which is not true. What happens in real time is there are no fire stops, there are unrated fire stops, there are cavities and fills. These small things play an important role in fire spread, and we should understand that we need to have a passive fire protection as a system, wherein we have the fire stops, the cavity fills, the sealants, along with the doors and the rated walls to create a fireproof system.
From Hilti, we have installed for 3 main applications which we see in any commercial building. One is electrical, second is pipe, and third is edge-to-slab fire stop systems. And we are seeing how long it restricts the fire in that compartment itself. In a facade fire, how fire grows is by 3 effects. One is leapfrog effect, second is chimney effect, and third is poke-through effect. This test will be to see how good fire stop system is to restrict the chimney effect fire.
We started the fire near the facade and we had distributed the fire load throughout the barriers. The spandrel area was made by masonry and concrete so that we wanted to force the fire to go from inside, if at all it goes to another story. So once the fire started, initially it's molded inside the room, and once the flashover took place, the fire was practically everywhere in the room, and the glass panes which were making the windows, all of those failed for the ground floor. And the aluminum frame that was holding the glass frames also melted away. Recorded data shows the temperatures were very easily 850 to 900 degrees Celsius. Throughout all of this time, there was no fire spread in any of the top floors, which indicates that it was stopped by the barrier that was installed.
The selection of the right fire stopping system for a particular application and its correct installation are crucial to ensure the proper functioning in case of fire. This also includes consideration of additional factors such as seismic movement, acoustics or airtightness. Therefore, to significantly increase the fire safety, two things are important. For one, the use of products tested according to their practical field of application, or to maximize safety, pre-engineered devices and systems. And second, to include all of this as early as the design phase.
This also highlights the urgency to evolve the building codes, where there is very limited direction on such fire stop system applications. Let's use tested fire stop systems to save lives, protect assets, and enhance building performance.
Time. Ultimately, how the fire happened, I will not go too much into detail, but there was a proper combustibility which was maintained as per the calorific value which was set, which is given in the NBC as well. And I will not go into this video. This is a very small video for an unrated fire stop system, which was local fire stop, not tested with anybody as per any guideline. The fire reached to the first floor within 5 to 6 minutes, and then up top within 13 minutes. So 13 minutes, the game is over. The moment fire reaches that place, toxic fume is already there. How will you evacuate? Because you can't see in that smoke. And then this test, the fire did not even go to the first floor for the entire duration of the test. We had to stop the test because we were thinking that steel will buckle and it might collapse the building for future test. So we had to stop the test. Now, these are the glimpses. I will just skip through. The plaster has come off. These are one of the glimpses. And then come to this graph. This graph is to tell you that for the one which has multiple graphs going on here and there, and then one on the other side which has only two graphs, very clean graph. The one which has many graphs, what it says is that temperature at the first floor, even the fire happened on the ground, but the temperature at the first floor reached 800 degrees C by around 15-20 minutes. It reached by 800 degrees C. Imagine what can happen if the temperature keeps on increasing the other floors. How will we evacuate? Suppose if we are at higher floors, 40 floors, 50 floors, high-rise buildings. And for hospitals, it becomes more important. And the other test, the temperature did not go even beyond 80 degrees C. So that was a thing. And then coming back to last slide, I will finish by this slide. So fire safety is something which has been known for as per various understandings. And fire safety is something which should be called off as a comprehensive approach by designers and by the people who are really going to take them, the clients, the real developers and the hospital owners. For them, every aspect should be very important. This is my own feeling, because they serve the community which will be most vulnerable to evacuate from the building. And if any loss of life happens, it will be very, very sad to see. Unfortunately, we have been improving on this subject, and NBC has done its part. Now it's all up to us to implement those changes. So from this, I would say thank you very much for giving this time.